Alright, so today we're looking at the present value of an annuity. A present value is when you, we know what annuity is, don't we? That's when we're putting a regular amount of money in over a period of time and we see what we get at the end. So the present value pretends that instead of putting in regular amounts over a period of time, what would it be if I just invested one lump sum right now, and it has to grow to the same amount? Okay, so if I just had my normal compound interest, I put a big pot of money in the bank account, left it there for however many years, we're going to work out what that number is to be the same as if I was making regular contributions every investment period. What number is going to give you the same value? Now, it sounds pretty complicated, but luckily for us, there's a very simple table. Now, your textbook has that table. It's on page 34. And it gives you the present value of annuity with a contribution of $1 per period. So obviously, most people don't invest $1 per period, so it's really simple just to multiply by whatever you would be investing. So we're going to look at using this table two different ways. The first way is we're going to say, all right, we're investing $500 or something each period. Let's work out what I could do as a single payment. The other way we're going to look at it is we're going to say, well, this is what the present value is, what payments would match that? Okay, so we're going to use the table either way. So this is the table, looks like this, very similar to the tables we did for future value, so make sure you read the heading. This is present value. So it's really important that you're using the right table, but of course in the test they have to give you the correct table, so that won't be too hard. So let's look at this example. We have Wesley. Wesley is going to save for a big holiday and he's going to deposit $1,000 in the account at the end of every 6 months for 4 years. So let's say he's at, he's at uni, he's doing a 4-year degree and he wants to go on a big holiday at the end. The interest on his account is 6% compounded half yearly. We're going to say, work out what would it be the same as if you could just invest one lump sum right now. So a couple of things in this question. Can you see the 6% is per annum, but it's compounding half yearly? So when it comes to the table, what would I use? So from the table, I'm looking for 3%, because it's 3% per half year. And what about how often? How many periods are there? Okay, so it's 4 years, but I have 8. Because I'm calculating every 6 months. So we're pretty good at using these tables by now. We're looking for 3%, 8 periods. So we go to our table, we go down the 3% until we find 8 periods, and this is the number here. Now this number tells me that if I was investing $1 every 6 months for 4 years, it's the same as investing $7.01 now. Okay? So all we're going to do is multiply that by 1,000. So 7.0197. Which is, yeah, not very tricky to work out. So $7,019.70. So Wesley could invest $7,019.70 right now, and at the end of 4 years, he'd have the same amount of money as if he invested $1,000 at the end of every 6 months. So that's what this table tells me. It tells me that this invested for 4 years at 6% compound every half year will give me the same answer as 1,000 invested every 6 months for 4 years. Does everyone understand what present value is now? Yeah. Okay. It doesn't tell me what it's worth at the end, does it? What do we call it if I'm trying to find what's worth at the end?
Future value.
The future value. So if I want to work out what it was worth at the end, I would use the future value rule.
Isn't it the same, just with different numbers?
Yeah, it's the same method, just different numbers. So I just times 1,000 by the future value table, not the present value.
Oh, so it's a different table?
Yeah, it's a different table.
How many tables are there?
Lots.
Real?
Okay? Yep.
So if we get the 10, so they give us the table.
They're going to give you the ones you need, okay?
Pay better.
Yeah.
It's not bloody.
Okay.
Fruits out.
Shh.
That's very
Okay,
hard.
so
With my bare
that-
hands.
I'll go over there and shoot all.
I thought, serve the bastard.
Serves the bastards rule.
Alright, we ready for the second example? You nearly ready? I can come back to this in a minute. I'll just go to the second example. Okay? So the second example is we can Nick. We can think of our annuity as paying off a loan, and our present value is the amount of money we've borrowed, and our contributions instead are repayments on that loan. So we're going to use the table to work out the repayments. So instead of taking our amount from the table and multiplying it, we're going to divide to work out what the payments would be. So we're just using the table in reverse. So we're still going to follow the same idea of finding your interest rate, finding the number of periods, but when we get the number from the table, we're going to divide whatever our present value is to work out what those contributions or those payments would be. So it's exactly the same way of finding the number, we're just going to divide by it rather than times. So do you understand when we would times and when we would divide? So we multiply when looking for the present value, but we're going to divide when looking for the contributions. Everyone got that clear? So multiply when finding the present value, divide when looking for the contributions. Okay. So, okay. Are you okay?
Are you serious?
That's not funny.
What's that? Where's it gone?
You right, Nick?
Okay.
Alright. Come on. Alright, can I come back to that?
No.
I can't come back to it.
That's funny.
Okay, we good?
Yes.
Alright. Second example, Rachel borrows 15,000. So this time we know the present value. She borrowed 15,000 right now. It's going to be 12% per annum. Repayable monthly for 5 years. She bought herself a car. What is she going to pay each month? And how much interest is she going to pay? So we know it's 12% monthly. Okay, so I have to change the question.
Oh.
I'm just going to
Yeah, one job.
No, we can cope with this.
better edit this out.
It's just that it doesn't work over 5 years. So
No,
we're
it
going to make
doesn't.
it. What's wrong? Why does?
Work over 5 years.
Yeah, because it only goes up to 12. The table's not big enough to go to
That's
16 payments.
more.
We can cope with
Change
this.
the form.
No.
Yes, we can.
No.
Yes, we can. We're just going to
No.
change the 5 years to 1 year.
1 year? Oh, that's even
We can
easier.
cope with that.
That's easy.
We can
That's-
go.
That's just one.
Okay.
Oh,
we
yeah,
good?
figured out now. It's probably one period.
Alright, so what's the interest rate going to be?
Who? 12%
12% per annum.
for one period.
How long is?
Monthly, 12 periods. No.
So what's the interest rate per period?
61944.
1% per period. 1% per month.
So it's 1 for 1.
Alright, she's going to pay it off in 1 year. So how many payments will there be? 12 payments.
So 1 for 12. 11.2551.
So looking at our table, we're going 1% for 12 periods. 11.2551. What are we doing with this number?
Timing it by 50.
Divided it.
Dividing.
And saves.
And that's going to give us the payments. So on our calculator, we type that in.
What's that figure?
what was it? 11.2551. Okay, shh. Boys. So her repayments are 1,332 and 73 cents per month. How do I work out how much interest, Josh? How do I work out how much interest she paid? Any ideas? Looking a bit lost? Yeah, so the first thing I've got to do, okay, to work out interest is I want to work out the total that she paid. So I know that she paid this every month for a year. So she's going to pay that 12 times. So 1332.73 is going to be paid 12 times, giving a total of 15.
And then you divide, and then minus 15,000 to do interest.
Well done. And 75 cents. So the 15,000 was the amount borrowed. So what was the interest?
Well,
Yeah. Okay, you're kind of happy with that?
Wait.
I'm just going to show you the questions that are back. Page 35, even questions. Okay? Page 35, even questions.